Hello, in this session we evaluate the enthalpy of reaction using bond energies. Now bond energies are simply the amount of energies required to form respective bonds. Now in this example we have carbon bonding with hydrogen, which is negative 54 kilojoules, oxygen bonding with oxygen to form oxygen molecule, negative 83 kilojoules, carbon bonding to oxygen, negative 97 kilojoules, and oxygen bonding to hydrogen, negative 98 kilojoules. Now, looking at the equation there, and the statement written above it says, using bond energies, find the enthalpy of reaction when a given sample of methane burns completely in oxygen gas, forming carbon dioxide gas and steam. Now, to begin with, to be able to compute the enthalpy of reaction, we have the formula delta H reaction is equivalent to delta H product minus delta H reactant. In other words, to get the enthalpy of reaction, we get the overall enthalpy of the product and subtract the enthalpy of reactants from that, which represents the change in energy and connotes the enthalpy of reaction. So then what do we do using these bond energies? The first thing to do is to identify all the bonds and quantify their respective overall energies. So in the first case, carbon bonds to hydrogen, there are 4 respective bonds of carbon joined to hydrogen in methane. Therefore, we would assume that this quantity of energy will be a multiple of 4. The second is oxygen bonding with oxygen, normally a double bond. So a given single bond, okay, this is a double bond. So oxygen and oxygen double bond is negative 83. So this is going to be a multiple of 3 based on the power that we have there. So we're going to say 3 times negative 83. And next, carbon to oxygen, we have negative 97. Again, it's carbon double bond O, assuming this is a double bond. So there are 2 double bonds of 97. So we say 2 times negative 97 kilojoules. For water is H and O. So we have H and O, H and O. 1 H and O is negative 97. So again we have negative 98 times 2. And there are 2 molecules also times 2. Now we are going to place that in the expression down here and see what value we obtain through that computation. So, 1, the enthalpy of reaction is the enthalpy of the product. The product in this case is negative 97 times 2 plus negative 98 times 2 and again times 2, because there are 2 molecules. So that is the product. So this product energy minus the reactant energy. The reactant constitutes 4 molecules of negative 54. So negative 54 times 4 respective bonds plus there we have O, which is negative 83. So it's negative 83 times the number of molecules, which are 3. So I'll put that outside the bracket. And then as we do the computation, what we get is negative 586 minus negative 465. Negative and negative gives us plus. The overall charge is negative 121 kilojoules. So there, the enthalpy of reaction is negative 121 kilojoules, showing that the energy required for forming the bonds of carbon dioxide and water respectively in that reaction is exothermic.